Hi, welcome to this breakout session. We are going to talk about how to embed intelligence or smart functionalities into our cloud applications. I am Alex, I'm a software engineer from Italy, and I work as a developer advocate with Amazon Web Services. Well, in my career, I've built a lot of web applications and AI integrations, and in my experience, it doesn't have to be a totally new application. It might be something that you have built in the past or an applications that you are currently building, and you just want to add a little bit of smart functionalities to make the life of your customers a bit easier. So here is the plan for this breakout session. I want to tell you about why are we even here, how we think about intelligence, what are these artificial intelligence services that everybody's talking about. I want to tell you about what is new in the stack. So some of the newest services and features that we have released in the last few months. And then I want to touch on two important concepts, in my opinion. The first one is what I call the bring your own data, because some of the services we're going to talk about, they kind of behave like a black box, meaning that you cannot really change the behavior of the services, while some of the other services we'll talk about, they allow you to build completely custom machine learning models starting from your own data, still without requiring a machine learning experience. But you can bring your own data sets and build something that is custom tailored for your own customers and for your use case. The second concept I want to talk about is what I call the building blocks approach. This idea that you can think of these AI services as a reusable microservice that you can bring into your cloud architecture without really having to understand or learn much about machine learning in general. So, ready? Great. So why are we here? What is this intelligence we are talking about? Well, whether you are building a web platform or an industrial IoT system or maybe an e-commerce, well, chances are that your customers have been getting used to smart functionalities, like maybe a user interface that can listen to them and talk back to them, or maybe some automation that allows the system to identify objects in images automatically, maybe count those objects in image, or maybe even something simpler like understanding sentences or searching into a large set of documents in a smart way. So let's say that intelligence in general is now expected into a lot of application spaces that we're not really expecting such an intelligence maybe 10 or even 5 years ago. This is exactly why we are here. The mission we want to have is to take all the experience that Amazon.com and Amazon Web Services have in the artificial intelligence space and bring it to every developer in the form of a simple API. In fact, if you can invoke an HTTP API, well, you can use all of these services. You don't have to, you don't need a machine learning or engineering or statistics background at all. If you can call an HTTP API, you're good. So this is the current stack. There is a lot of new stuff in there. We're going to dive into some of these services. You probably already heard or used Amazon Recognition or Amazon Poly or Amazon Comprehend to deal with images and text and natural language processing. Now today I want to focus on some of the newest services, and some of the services that allow you to bring new data, your own data, into the system. So we're going to focus on the top side of this stack. We're not going to talk about machine learning frameworks and TensorFlow and Amazon SageMaker. Okay, these are great tools if you want to build completely new models that solve problems that haven't really been solved yet, and that's great. But there are a lot of AI services, that's how we call them, that allow you to solve problems that, let's say, have been solved in the industry, and we have these models that we keep updating and improving every week, every month, so that you have to think about it. Now, let me tell you about what is new in this stack. There's been a lot of evolution, a lot of new features, a lot of new services, so let me tell you about it. Maybe you have heard some of these coming from AWS reInvent 2019, but let's review what's up there. So Amazon Kendra, this is a service that, in just a few words, it allows you to search documents in a smart way. So it's in the AI section, let's say, because it can do what it does by using intelligence. So it allows you to connect a set of documents from a lot of different data sources, and then it provides you with a user interface that you can use as a search engine, basically. So simply put, you just connect some of these data sources. It might have been something on Amazon S3 if you have already objects stored, or it could be a database or an email system, or maybe a third-party service like Dropbox, Box, Drive, Salesforce, and whatnot. Once you have connected your service, Kendra will build an index. So you create an index, you specify where is the data. Kendra will go and fetch all the data. Actually, it will do it periodically. And then you add your data source. And once your data source is in there and the index is loaded, what you get is this nice user interface that is very intuitive, and it even allows you to fine-tune some of the search results. So if you think that a specific field in your dataset requires more relevance, like a date or the number of the page views that a given document received, you can go and fine-tune it to customize the experience. Next up, Amazon Code Guru. This is great for developers. If what you're doing is writing code and code reviewing your peers' code in a team, doing a lot of pull requests and code review sessions, Code Guru is basically another developer in your team that can help you review the code that your team writes. So not just that, it actually has two main features. The first one is the Code Guru Reviewer. So it acts as an additional code review in your team. The second feature is the Code Guru Profiler. So simply put, it allows you to find the most expensive line of code in your code base. Why? Well, imagine that your code is running on a large fleet or a large cluster of instances or virtual machines. Well, chances are that if you can identify and fix the most expensive lines in your code, you can also reduce the infrastructural cost that is required to run that code base. And I'll give you some examples in a second. So let's talk about the reviewer for a second. The idea here is that you integrate Code Guru into your versioning system. It could be a Git repository, for example. So you work on your branch, you make changes locally, then you open a pull request. Well, what happens now is that you, your team, your peers will go and review that code. Well, Code Guru is going to join you there and add comments and help you with the process of reviewing this new code. How can it help you, and how is it different from a static code analyzer, for example? Well, first of all, it helps you with AWS best practices. So it's been optimized, and that's why it's a smart service, to deal with the way you use AWS services. For example, how you deal with polling or paginations or things that are easy to miss. Second, it helps you with concurrency. So imagine that you have synchronizations issues or performance issue due to concurrency in your code, like multi-threading and things like that. It can help you a lot. And then resource leaks and sensitive information and code defects based on or on mining data. So it's not just a static code analyzer, it's based on millions and millions of lines of code that at Amazon.com we write every year, basically. So it's based on history. You can integrate it into your versioning system and it will help you detect issues, basically. It could be a data structure that could be optimized, or it could be, I don't know, a pagination issue, or maybe a better, more optimal way to deal with polling, for example. And these things, you think it's just a couple of lines of code changes, but sometimes, especially if you run on services that you pay per, as in a pay-per-use model, it's likely that it might help you spend less on your infrastructure cost as well. The second feature is the Code Guru Profiler. So the profiler, you integrate it for example, with your unit test or your integration tests, and it will analyze every single line of code during the execution to understand what the CPU utilization, and ultimately it will help you identify the most expensive lines in your code base. You can also visualize this, so it will give you a nice chart to visualize it and to have an idea of where the time is spent during the execution. Now, let me give you an example. During Amazon Prime Day in 2018, we tested CodeGuru internally. It wasn't available externally, but CodeGuru is a great example of how Amazon.com innovates internally, and then we release it externally to every customer out there. So what happened is that between 2017 and 2018, between the two Amazon Prime Days, this yearly event, one of the largest events for Amazon.com, the retailer, we used CodeGuru to optimize the code that was running under the hood. What happens is that it did identify a line of code that was causing a major performance issue automatically. And because of that line of code, I think it was a data structure change, something like a hash map kind of structure that was more performant, it was able to increase the performance of the whole cluster. So we were able to reduce the cost of the cluster almost 40%. So imagine that at Amazon scale. Pretty impressive. I have to tell you, CodeGuru right now supports only Java, but we're planning to support more languages, of course. Next up is Amazon Fraud Detector. As you can imagine from the name, the service allows you to detect frauds online quickly, more often, and automatically. It's one of those services that I've already mentioned that help you with creating models that are custom designed, providing your own data. So we'll see a few more of these services later. The idea here that the main use case, think of e-commerce. Maybe you have an e-commerce platform and you are accepting, transactions to buy items from your catalog, and you want to identify which ones of those transactions are frauds. So what do? Well, you can integrate your website with a fraud detector. It's a very simple API integration. As I was saying, if you can invoke an HTTP API, you can integrate most of these services. So what happens is that your customer will give you the transaction information, maybe to your web server, to your website, and then you can invoke fraud detector with that same information after you have trained it with your historical data. And fraud detector will be able to tell you if it's a fraud or not. Based on the accuracy, based on the precision of the model itself, you'll be able to use that information to confirm the transaction or deny the transaction. Very simply put. Next up is Amazon Augmented AI. So this service is super useful if you have developed your own machine learning models, but also if you're using services like Amazon Recognition or Amazon Text Track. That we'll talk about them in a second. So usually what happens is that you deploy your models to production and they will have a given precision, a given accuracy, let's say. And it could be 95% or even 99% sometimes. But there is still that 1% of cases that are not going to be handled very well by the model. That's totally expected. It's kind of hard, if not impossible, to reach 100% accuracy. So what happens is that you want to take that 1, 2, or 3% of the production data that is not being handled correctly by the model, and you want to create a virtuous loop and create that data and use it manually, label it, tag it, analyze it, and then use it for the next iteration of the training of your model. So this is great because it provides this feedback loop automatically. So it will be able to detect those issues and go back and provide that information back for you for the next retraining of the model. Same if you're using text strat or recognition for example, the custom labels that we'll talk about in a second. So let me tell you a little bit about text strat itself. We call it OCR++. So it's not super new. It's been there for a bit more than a year, maybe a year and a half. And It's OCR, it's optical character recognition, but not regular. It's plus plus, right? So because the typical OCR system will give you, hey, at coordinate x 10, y 20, okay, there is a number, or there is a word, or there is a character. Okay, that's great, but in most cases you want something more high level. You don't want to operate at that very low level of abstraction. You want something like advanced text extraction, or imagine you want to do that for structured data. Imagine you have a table with a lot of numbers and columns and percentages, or imagine you have a module or a form where someone has entered information either digitally, maybe in a PDF, or maybe manually, and then they scanned the document, and now you have to digitalize this document. How do you do that? It's kind of hard with traditional OCR. So Textrat is a smart service. It does OCR under the hood for you, and then it provides enhanced high-level information in a structured way, so that you can use that information, store it in a database table, or do whatever you want with it. I've tried it a few times with tax documents, for example. It worked pretty well, and as I mentioned before, these services get better and better every week, because the API, the interface is exactly the same, but the model under the hood keeps getting better and better. Use cases, well, imagine again financial documents or healthcare or government documents. I think in general everything that needs to be digitalized is a great fit. It could be great also for books or for other documents that you just want to digitalize and create a digital archive of these physical documents. But I think the best use case is where you want to digitalize super quickly and automatically thousands, if not millions, of modules and forms that people have filled out. And you want to collect data quickly and maybe build a dashboard and analyze data quickly. I want to give you an example. This is a CRIF. This is a company from Italy. They have built a document management applications. They came from an on-premises implementation that was too expensive and only allowed them to have 10% of the documents they wanted to digitalize available to their customers. And so they built a new implementation of this using Amazon Textrat. And this new solution is 25% cheaper while allowing them to have all the documents available to their customers. Also, they tried initially to create their own OCR system, and they reached a precision of about 60 to 65%. With Textrat, out of the box, just with a few API calls, they already reached more than 75, 78% accuracy, which is a pretty good improvement, given that you don't even need a data science or machine learning experience to take care of this process. So their goal is by 2020, by later this year, to have 100% of their physical archive available online. So it will be securely stored on Amazon S3, digitally processed, maybe even searchable and analyzed at the semantic level, so their customers can have another tool to look for these documents. Let me also tell you about recognition. You've probably heard of it. It allows you to do a lot of different things. Basically, each and every one of these features has its own API. So there is an API to find objects in the image. There is an API to detect text. So it's kind of a simpler OCR mechanism if there is very little text in a picture, maybe. Or you can do face search and face comparison. Maybe you can create an index of faces and then detect whether those faces are available in the index. And it doesn't work only for images, it also works with videos. So all these features are available with videos as well. And you can also do even more with videos. Imagine you can do activity tracking or object tracking within the different frames of the video. Now, this is great. Let me give you an example of this. This is a customer from Sweden, Hemnet. It's one of the largest property portal in the world. So they had this problem. Okay, first of all, they have more than 3 million visitors every week. and they've been using AWS for more than a couple of years now. But they had this problem. They wanted to simplify the life of their broker agents. They had a lot of images, as you can imagine, coming into the platform every single day. They wanted to automate the process of finding detailed information about each single property, like how many floors does it have, and what does the house look like, and things like that. So they managed to use Amazon recognition to automate that process. So now label detection is used on every incoming image in their image analysis pipeline, and then this information is automatically extracted and made available to their customers without any manual work from their brokers. So I think this is great. And in the meantime, they could also leverage another feature of recognition with this image moderation. So with another API call, you can just say, hey, is there any nudity or violence in this image? And this allows them to make all these images compliant with their publishing rules without having to reinvent the wheel or create another new machine learning model. So now let's get into the interesting part, actually. I've mentioned that recognition and most of the services we talked about so far, they act as a black box. You can find objects in an image, great, but what if the object you want to find is not automatically recognized by Amazon recognition? For example, I met some students, some friends in South Africa last year, and they wanted to find different avocado species in their images. It was an industrial system, I guess. And well, recognition does not recognize avocado species yet, at least. So what they can do is that they can bring their own data. They can build an avocado species data set and now use what we call Amazon recognition custom labels. Now, this is not the only option. We have already seen Amazon fraud detector. I also want to share with you Amazon Personalize and Amazon forecast. So all these 4 services now allow you to bring your own custom data to build a custom model that works for your customers. Let me tell you about custom labels. So again, imagine you want to recognize something that is very specific to your use case. What you do? Well, you build your simple data set, maybe a few hundred images for each object or class that you want to recognize. It could be a product, it could be a logo, it could be comics or characters if you are in the media or publishing space, or it could be something biological like an animal or a species of plant or fruit. How do you do that? Well, first of all, you upload these images to S3, and then you just tell recognition, hey, go and find my custom data set and build a custom model for me, starting from that. So what recognition will do is it will apply some transfer learning. So it will start from an already solid model. That's what you would do in the industry. You don't start from scratch building a model. It starts with the already existing recognition model, and it will add some additional. It will enhance it, adding some additional information about your custom data set, so that after a few minutes or hours, depending on how much data and how complex it is, you will have a custom endpoint that you can invoke passing a new image. You will get the results back. So the final interface for you is basically the same. You just have this additional step of uploading and analyzing the custom labels that you want to be recognized. Let me tell you about Amazon Forecast. So forecast is interesting. It's not weather forecast, first of all. It allows you to recognize the next number in a series of numbers. Imagine you have some time series data set. It could be the value of a stock or the value of a physical object, or maybe if you are into logistics, it could be, how many items in my warehouse do I need to support customer demand? This is typical retail use case. Now, inside Amazon, at Amazon.com, we've been doing this for decades already, since 1995. Now, the initial methods, the traditional methods, are statistical statistics based. They work, especially if you have seasonal demand and you can predict that a specific object will be available or required only, only in winter, or only in a specific area, also in autumn. There are a lot of seasonal patterns that are easy to spot. If you have a lot of items, say millions and millions of items, we started using machine learning back in 2007 to be able to not only be based on statistics, but also to try to predict what some customers would want to buy. Like, imagine, okay, this item is getting super trendy, so because you like this, it's very likely that you probably want to buy this other item too. So the correlation. Now, in 2015, we started adding deep learning to our set of techniques. And as you can imagine, the accuracy increased a lot, almost 15 times better accuracy. Better accuracy means it's more likely that you show a potential customer something that they're actually interested in buying in the retail world. So internally, we built Amazon Forecast that is now available to you as well. So similarly to fraud detector that I mentioned before, and to recognition custom labels, Forecast allows you to provide input data. In this case, we're talking about historical data, so who bought what. For example, if you are in the retail space, what's your inventory, what customers can buy, and what's been the demand so far. You can provide even additional data, related data. It could be the price of the items and what promotion is currently active, or maybe some custom data or custom events that you want to provide. And then some metadata, maybe about the items, maybe about the customers, so you can try to match those as well. Now, after you provide this data, it is a black box. So everything that happens inside, it's all about finding the right model, features engineering, which feature is more interesting and useful to predict the best set of items. Okay, once all of this happens, but might take a while, what you get as output is a private forecasting API. A simple API that you can use where you say, hey, I have this customer, this user, what do I... Actually, this is for Personalize. We'll talk about that in a second. So the mechanism is exactly the same. But in this case, we don't want to try to guess what you want to buy. We want to guess, for example, how many items of this particular type we want to have in the warehouse. So even though the initial data might be the same for Amazon Forecast and Amazon Personalize that we'll see in a second, in this case, we want to be able to try to predict how many books or how many shoes or how many items we need to have in the warehouse in the next 2 months. So what's the next number in the time series? Let's make an example. Imagine we have the data up to today and we want to predict how many of those items we need to have in the next few days or weeks. Now, there are different ways to do it. Usually you want to use some sort of a quantile. So what's a quantile? Imagine you want to ask Forecast something like, hey, imagine I want to make sure that 10 times out of 100 the demand will be lower than how many items I have in my warehouse. So it's not a very safe choice, but you want to do that when the cost of over provisioning these items in your warehouses, for example, is too high. You cannot really afford overstocking because it's too expensive. So if you buy too many items and then customers don't want it, that's a big cost for you. On the other hand, if that's not a problem and overstocking is not a big problem as far as cost or as far as space, well, you can maybe use a quantile, something like P90, where you want to ask for a forecast that tells you that the real number, the true customer demand, will be lower than the forecasted value 90% of the time, 90 times out of 100. So in this case, you really want to make sure that you have enough items in your warehouse to support customer demand. Now, since a few months, Amazon Forecast even allows you to customize these quantiles. So imagine you want to have a quantile of 10. By default, you have 10, 50, and 90, but you can even customize it. So imagine you want to have a quantile of P99. So you want to make sure the number you forecast is higher than the true customer demand 99% of the time. Now, you really want to make sure you have those items stocked, meaning that it's not super costly for you to have them in the warehouse as far as cost or space. You can customize this. You can tune Amazon Forecast to give you the best quantile. You might actually get multiple quantiles back. So you can say, hey, give me P20, P50, and P95, because that's what you need to make a best and worst case scenario forecasting. So it's super flexible. You decide how many quantiles and so how much you pay as well. And that's it. Then you can, of course, retrieve this data via API if you want to automate the whole process, or you can even download it as CSV if you want to have a more manual process and provide humans or other systems that can deal with CSV, all these forecasted values. Now let's talk about Amazon Personalize. So imagine a similar scenario, but we don't want to forecast, we don't want to try to guess how many items we need in the warehouse, but we want to guess what our customers are likely to buy. Or if you are on Netflix, what movie they would like to watch. Or, we want to build a recommendation engine. We want to be able to recommend the best items to each individual customer. So typically you do this by building a recommendation engine that needs historical data, related site data, and metadata about items and customers and users. So the input data set is pretty similar to what we saw with Amazon Forecast, if you think about the typical retail example. So Personalize is exactly the same. You provide input data. It does a lot of things behind the hoods. It finds the best features. It finds seasonalities. It finds correlation between similar users. It does a lot of all of that for you without you having no machine learning experience. And then it provides a custom API for you to say, hey, I have this user right now on the website. Which movies or which items or which whatever should I recommend him or her? Similar mechanism, provide events, provide interactions. In this personalization use case, you might even provide different levels of interaction. You might say, this user in the past visualized the page of this item, but she didn't buy it. Okay, so that's a lower weight interaction if you think about it. So you may design what that means in your application, in your system, but then you provide that data structured and shaped in that way. Then you want to provide a catalog, what are the items, what are the metadata, and then you want to provide some demographic metadata about the users too. Everything happens under the hood, and then you get the customized API, as we have seen already. Let's do an example. Let's see how it might work technically in a real world. Imagine you have your three-tier architecture. You have your web server, you have your database, you have the client-side application, maybe in a browser or in a mobile application. What happens is that your client side can stream data straight into Amazon Personalize. Something like, hey, I viewed this item, I've bought this item, or whatever happens in the client. And then at some point it can ask to your web server, hey, what should I recommend? What items should I show to this specific user? Well, your web server, your application server can just ask the same question back to Personalize that will come back with an answer. It could be a JSON response, and you reshape it, you filter it, you store it somewhere if needed, and then you return it back to the client. That's it. What typically happens is that in that middle tier, in that application layer, you maybe want to enrich, you probably want to enrich this data coming from Personalize. Maybe you have a more updated price, or maybe you have a promotion going on. So you want to have that middle tier, that application layer, reshaping the object coming from Personalize all the way to the client. But that's basically the mechanism. Now, I also want to tell you about what I call the building block approach. What is that? I've mentioned many times that you do not need any machine learning experience, okay, and that's great. Why? Because all you need is an HTTP call. Now, if you accept that, when you really deeply understand that, you can start thinking of your cloud architectures differently. You can start saying, okay, I've developed my website, I've developed my front end, I have my database model. Now I need a smart functionalities. What do I do? Oh, it's about finding objects in image, or I need the next number in this time series, or I need to transform text into audio or audio into text. Okay, you can think of that problem as something that a microservice can solve you. So what you do, you go and find the best brick, the best building blocks available into your cloud building blocks tool set, and you just integrate it into your cloud architecture. One of the best things I haven't mentioned yet is that most of these services have a pay-as-you-go model, meaning that if you don't use them this month, you pay zero. If you use up to a free tier limit for the first 12 months, you also pay zero. And just to give you an example, Amazon Recognition, you pay based on how many images you analyze. Amazon Poly, where it allows you to do text-to-speech, you pay based on how many characters you render from text to audio. So it's fairly easy to predict how much you're going to spend next month. And there is no commitment, there's no long-term contract. You can just say, I'm probably going to render 2 million characters in the next 2 months. Great. How much is that? Maybe a couple of dollars. Done. That's all you need. And you can integrate it, see if it works. If it doesn't, if the quality is not enough, you haven't committed. You don't have a long-term contract. Okay, it doesn't work for you. Maybe it works for you in an MVP phase if you're building a startup. And then at some point you realize that's the core part of your business, and you probably want to build a custom model and try to reach different accuracy or to integrate other features that some of these services may not have yet. Now, I also want to show you how easy it is to use these services. This is the Python. Okay, if you don't know Python, the syntax is fairly similar in Node.js and in Java and in PHP. This is using Boto 3, the AWS SDK for Python. But basically what you do is you initialize the client object. In this case, I gave it the name of the service, like comprehend or poly or translate or texttract. And then you typically invoke one API. It could be, in the case of texttract, on the top right, detect document text. In this case, all I need to do is give it a document. It could be a stream of bytes if I have the documents right now in memory, or it could be a reference to Amazon S3 if I've stored that document on Amazon S3. And this pattern is pretty similar. If you look at comprehend or poly or translate, I also want to show you the same for the bring your own data services, where you have recognition custom labels, you have recognition.detect custom labels. And the interface is pretty much the same for every programming language that have an AWS SDK available. Fraud detection, the same. Personalize, the same. Forecast, the same. Some of these have some advanced features like filtering, like start date and end date for Amazon Forecast, or maybe you want to provide a user ID and item ID with Personalize, or you want to provide a unique event ID for fraud detection. So all you need to do is go and check the documentation of these API calls. Of course, there are many other API operations that are, for example, for these services, like creating the model, providing your own data as input. But once you have done that, this is how you integrate them into your systems, whether it is an IoT system, a web application, or whatever you're building. So I really want to stress this point that you can think of these services as building blocks, that you pick and choose what you need. If you don't need them anymore, forget about it, integrate something else, or even build your custom models on Amazon SageMaker using TensorFlow or Keras or MXNet and whatnot. You want to learn more about these things? Well, you can check out these websites, ai.aws and ml.aws. Here you find resources and customer use cases and links to articles and videos and tutorials. So that's a great place to learn more about the technology, about the AI services, and also the rest of the machine learning stack of Amazon Web Services. I also wanted to share another link, aiservices.goaws.com. This is a practical workshop that will teach you how to use some of these services. So if you're a developer, if you are an IT professional and really want to get your hands dirty with some of these AI services, basically for free, because they all have some sort of free tier that allows you to experiment and see if they work or not for a use case. So feel free to experiment. That's my best recommendation. Feel free to experiment, to try them, to see if it works for you, to see if you can easily integrate some smart functionalities into your existing application or the next application you're going to build next month. Thank you for watching. I also want to remind you that you can find and meet some of the machine learning and IoT competency partners in the partner discovery zone. So feel free to drop a message there, feel free to discover them and say hi. These are partners that work with this technology every single day and might help you with your next project as well. So thank you for watching. I hope you learned something new about artificial intelligence and smart functionalities. You do not need a machine learning experience to integrate these AI services, and I think that's the best thing you could learn today. Thank you for watching.